So first we will let you do, then we will continue. And A is 11, then chlorine is 17. So sodium is 281, and you will lose this one electron. So you draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then chlorine is 17, so it's 287. So it will take in 1. Okay. So once you take in 1, what is this here? Is this a dot? I assume this is a dot. It's a dot, right? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, here. Okay. Correct. Then you need to put the key. Of sodium dot electron of chlorine, like that. Number 2, predict whether the compound has high melting point or low melting point. Then you have to explain your answer. Okay, predict whether the compound has high melting or boiling point. That's one. And then second, explain your answer. So two parts here. It has high melting boiling point to overcome strong electrostatic
forces of attraction.
yes between sodium
between
and
the cation and the anion.
in this case you have to say it's sodium ion and chloride ion. Okay, must be specific. Overcome, it needs a lot of energy to overcome the strong electrostatic forces of attraction between sodium and chloride ion. Standard answer, every time just write this if it's an ionic compound. Okay. If you see a question that's like this, that is ionic compound, and then they ask you for whether it's high melting and boiling point, you just give them this answer. They ask you for the reason, you give them, oh, it needs a lot of energy to overcome the strong electrostatic forces of attraction between sodium and chloride ion. Okay? Always
Why
this answer.
cannot say between the cation and the anion?
Because your question, now your answer must be specific to the question. So now they say sodium ion and chloride ion. So you have to write sodium ion and chloride ion. It's writing to the answer. If you write sodium between the cation and anion, right, it looks like your answer is just lifted off from some other book. So you're not answering the question.
Means anywhere they can just say of the cation and the anion.
Of the cation ion, if they never tell you who is the positive ion, who is the negative ion, then you can say then it's positive and negative ion. Predict the compound, okay, whether the compound can conduct electricity or not. So we are at part 3. Predict whether it can conduct electricity or not. When does this compound conduct electricity?
In the molten or in the aqueous of molten state.
Okay, correct. Part B. I would like to go through some the physical properties and of ionic and covalent compound again. Okay, so it's like this. We have two kinds of compound in your syllabus. Just one is the ionic compound and two is the covalent compound. The ionic compounds are usually made up of non-metal and metal elements. So they exist in ion form in a crystal lattice that you know. Okay, so they are in this format, they are in this arrangement. So this they can, because of this they conduct electricity in molten and aqueous state. Then do not conduct electricity in solid state. Then they dissolve in water only. Then they also have high melting and boiling point. This is the ones that I can remember. Okay. Then for covalent compound, there are two types. There is the simple molecular structure.
Intermolecular structure.
Simple molecular structure or simple covalent compound, they call it. This is the one you learn. There's another one which is giant molecular structure. That one is not tested for you. So this, right, they exist in molecules. Then they have low melting and boiling point because they have low melting boiling point because of the weak intermolecular forces of attraction. Cannot see if I use white over there. Then they they are insoluble in water, soluble in organic solvent. Then what else? They do not conduct electricity. They do not conduct electricity. I cannot use that. Okay, like that. Something like that. That is what I can remember. So from here, right, in your chart down here, you can identify who is simple molecular and who is who is simple molecular, who is ionic. And of course, there are two more, which is the giant macromolecules that you've not learned, and also the metals you don't learn. Okay, metals is they assume you know, which is conduct electricity at all states. Then they have high melting boiling point, etc., etc. Those are from primary school and lower sec, so they assume you know. Okay, so you have substance A, B, C, D. Now we want to identify what they are. So we have substance A. It's the melting point is quite low, but it's a good conductor in solid state and liquid state. So this substance should be a metal. Then E, right, is also good conductor of electricity in solid and liquid state. So this is also a then we have B, C, and D. The two here, right, that do not conduct electricity at all states, these are covalent compound. Then the one with low boiling point will be the simple covalent compound. Then the big one here is not the simple one, it's the macromolecule that you don't learn. Okay, don't learn doesn't mean they cannot put it there. They can put it there and you use elimination to eliminate it. That's why it's there. Okay, D, right, it's one good conductor and one poor conductor. Then it has high melting point. So this is ionic. So part A, which substance is composed of small covalent molecule? After so much rubbish I talk so long, do you want to change your answer? So a substance that is composed of small covalent molecules, right, are simple covalent compound. That's why this is actually C. A non-conductor of electricity in any state. You want to read the question again? So you can put B or C. Then which one is slightly to be soluble in water, slightly soluble in water, but insoluble in organic solvent?
D.
Yeah, D. Because it's ionic, so it is soluble in water, but unlikely to be soluble in covalent of organic compounds.